Hi everyone. So in week 3, we're going to do lab 2. So you should log on to Canvas and click on modules and scroll down and go and click on the free fall body file. Okay. So the objective of this experiment is to find the acceleration. We know that when you have an object that undergoes free fall acceleration, it experiences a constant acceleration, and that acceleration is what we call the free fall acceleration. And so, so the equation is that if you remember using the one of the equations for kinematic equations, the final position is equal to initial position, why not? This is y, and then plus the initial velocity in the vertical direction times time, and then plus the 1/2 at squared, right? A is the constant acceleration. Now in this experiment, since it starts from rest, there's no initial velocity. And then when you move this to the other side, which is displacement, we're going to use D to indicate that's displacement. So y minus y naught is displacement, and that's equal to 1/2 at squared. So in this experiment, you're going to change the separation or the displacement, and then the system, the sensor is going to measure time. So once you have the separation or the displacement value, and when you have the time information, then you can do a plot. When you plot the displacement versus 1/2 t squared, then that in this case the D is already we make it positive. So in this case you will have when you plot 1/2 t squared, so you can see that the slope is going to give you the acceleration. So from the experimental value of the acceleration is coming from is by do a line fit of the data of D versus 1/2 t squared. So when you get the slope, that is going to give you the experimental value of A, the free fall acceleration, and you're going to compare it to the theoretical value, which is, or the actual value, which is 9.8 meter per second square on the sea level. Okay, so that's basically what the experiment is about. You want to the setup is like this. So you would have so let me just scroll up a little bit. So you have, so you have something like this. So so you have a draw box, and then there's there's a magnet on the draw box, and the ball itself has the magnet as well, and you're going to attach the ball to the draw box, and below is a sensor. So you would start you would start by giving the separation between the bottom of the ball to the top of the sensor, giving it 40 centimeters, and you press the button, and then when you press the button, the draw box is going to release the ball, and the system is going to measure time, and you're going to increase the separation by 10 centimeters each time, so that you're going to get data. You're going to get 10 data points, meaning that you start from 40 centimeters separation, increase 10 centimeters each time, and you're going to increase it up to 130 centimeters. And each time you're going to measure the flight time when you release the ball. And the data will be, the data table will structure like this. So you have, let me just scroll down. So you have the heavy ball, you have the light ball, and each time you start from 40 centimeters all the way to 130 centimeters, and each time there's a time measured. So altogether you have the 10 data points, and then there's a what we call the heavy ball, and the light ball. So given the same consideration, given the same conditions, we want to find the free fall acceleration. That is, one is when we use a heavy ball, and one is when we use a light ball. So so when you write the report, you need to discuss, what is the difference between, you're going to get acceleration from each scenario, and you're going to do a comparison between those two scenarios, and then compare it to the actual value 9.8, and discuss why one has a lower error than the other. Okay, and I think there's questions in the analysis as well. So when you write out the report, remember to answer the question. And also when you do the plotting, there's actually suggested title, like free fall, heavy ball, and for the heavy ball, and free fall body, you can change a small light ball when you're using a light ball data. Okay, so for all the lab activity, when you are asked to do plotting, there's always, just read through analysis. This is just suggested title, chart title, a better title. I don't want you to say this is X, this is Y versus X, because you're already plotting Y versus X. There's no need to repeat it in the chart title. Okay, so that's basically, today's experiment is very easy to do. And let me see, let me click on the module and then bring out the data. So the data will look like this. So scroll down, and of course I'm going to upload recording, once I have it available, to this lab instructions recordings. You want to scroll down and then click on lab data, free fall body data. Okay, and you see that the data are in the Word document. So you need to key in those data to the Excel file, and use Excel to analyze the data. So let me show you. Let me start sharing, and then let me share the other file, the Excel file. So additionally, in addition to finding the free fall acceleration using the data, one of the things that you want to learn from this experiment is to learn how to use Excel to do further data analysis, and also how to do a plotting using Excel. Okay, so let's say artificially, not like we have a set of data. So we have the height separation, and this is already converted to meters. So so right now I'm just going to give like five data points, and and then let's say we have arbitrary numbers. Let's say time, this is in seconds, 1 2 3 4 5. And so during the plotting, remember the equations of motion says that the displacement, which is the h, is proportional to 1/2 t squared, and you have the t, so you need to calculate 1/2 t squared before you do the plotting. So the other thing is that when you're killing the data to the Excel, you want to make sure that you convert centimeters to meters. Okay, so 40 centimeters becomes 0.4 meters, and so forth. So let's say whenever you want to do calculation, you click on the empty cell. So now I'm click on the empty cell, and I click, I enter equals, and I key in 0.5, and then multiply. I use start, and then t. So I click on this cell, okay, and then caret, and then 2. That will be the square, and then hit enters. Okay, so this is how you do the 1/2 t squared. You key in equals 0.5, and then times, and then click on the cells, which is C4, and then caret and square. And then once you click on, once you calculate the first value, you click on this, and then move your mouse until you see the solid cross, and drag it downward. Okay, and then you get your 1/2 t squared calculated automatically for you. I don't want you to use your calculator to do 1/2 t squared. You want to organize your data so that you have the height, you have the time, you have the 1/2 t squared for the light ball and for the heavy ball. So now I'm going to do a plotting, because we want to do the scalar plot. You read through the instructions in the analysis. You're asked to do a scalar plot. So how do we do the scalar plot? So the first thing you do is that click on insert, okay, and then you click on, and then you can see that there's a lot of stuff here. Let me see. So click on this drop down menu, and it says scalar plot. So maybe that just I think we want to use the scalar line plot, smooth line. Maybe let's do this one. Okay, so click on the scalar plot. Okay, and then And then what you want to do is that, okay, once we have that, so let me use it small. Yeah, let me just do it. Okay, let me just show you. Once you have that, then we want to, you see here on the top, it says select data. So we click on that, and then you click on add, okay? And then the so you can finish that later, the series name, whatever you want to call that. And then maybe like, let's say this is for light bulb. So let me just do that, okay? The x value, your x value is the 1/2 t². So select that, and then click on this this icon again. Your y value is the height, is a separation. So click on that, and then select the data, okay, and then hit the icon again, and hit OK, and then hit OK. So you can see that you already have this, and then this one actually, you know, you can change that later. You can change it. For example, the chart style. Let me see. You can just change it. You know, for example, double click on that. I think you can say that the free ball body. And then dash, and then light bulb, okay? And then you can also change the you can also add you know, the x-axis and y-axis. So click on this chart, and you can see add. So click on that, and then you can see that this will give you the you know, options to do the to add the axis titles for the x and y. Okay, let's say if you go on that, let's say if we do that, you can change. Let's say, let me just say CCC, whatever. Okay, can delete that. Let me just. And then for this one, just click on that, and let's say that's AAA. Okay, and you do that, right? Okay, and then you know, you want to include the units, so whatever units that I don't know. I mean, like for this one, this is times square, so you can do that. Second square, sorry, second square. Okay, all right. And so you can see that, close that. So you can see that you can just click on the add, this one, and it shows the chart elements. You can you know, have the add the axis, or add the chart title, change the chart title, add the axis title, and things like that. So now the grid line, you can just remove that if that looks too busy. Legend is let's say if you have more than just one lines on the on the chart, then definitely you want to label that, use the legend. Trend line, so this is the one that you definitely want to do because we want to find the slope. So click on that, okay, and then click on this you know, this arrow, and then we want to do linear, okay, and you want to click on the more options, and then click on linear, and then the thing you want to do is that you want to display equations on chart so that you have this, okay, and then move it a little bit away from the line so that you can you know, so that people can see the values clearly. So you can see that, so this is the y value, and then you have the x value, and in front of the x value, that is the slope. This is the one that you should, the value that you should jot down, and then compare it to 9.8 once you use the actual data. And then this is just the intercept, okay? So create one figure like this, and then create one for the heavy ball, and then you know, this goes from 0.4 all the way to 1.3, and then the time is whatever the data you're given, and then create the you know, use the third column to create the 1/2 t², okay? And then lastly, once you have your data, once you know, have you know, adding the whistle and bells, remember you also need to add figure caption for each figure. So the figure caption is you know, is a few sentences to describe what this figure is about. You don't want to say that this is you know, displacement versus 1/2 t², because you are already implying this. I see that. So you want to give more meaning to that figure, so that people, when they look at this, when they look at the whatever information that's been provided by the figure, and then they read your caption to gain a better, a more understanding or more concept from this figure. For example, I won't give you an example, but you just need to figure out what you need to write to describe this figure without repeating whatever information that's already in here, okay? So that's basically what you want to do for lab 2. Like I said, it's a very easy experiment. The data analysis is very easy. It's two figures are needed, and you need to do sample calculation. And sample calculation, I think the percent sample calculation will be sufficient for this particular experiment. Okay. All right. So so that is it.